Regarding asteroids, there are theories that suggest that they might have planted the ingredients for life on Earth. The key point would be to know how much water they have, which would be considered evidence of how they helped plant the seeds of life on Earth. There are two ongoing missions that may provide an answer to this question: the Japanese Hayabusa 2 mission to the asteroid Ryugu, and NASA's OSIRIS-REx mission to the asteroid Bennu. Both missions will collect asteroidal materials and bring them back to Earth for in-depth analysis.
The OSIRIS-REx mission to asteroid Bennu is a sample return mission to detect amino acids on an asteroid and bring back a pristine sample to Earth for study here.
We will learn a lot from comparing the two asteroids, Bennu and Ryugu, and understand the similarities and differences between their samples. The first one to be launched was JAXA's Hayabusa 2 mission, a mission of the Japanese Aerospace Exploration Agency that left Earth in December 2014.
A Hayabusa 2 mission is visiting an asteroid called Ryugu. It's about 1 kilometer across. It also seems to be a primitive carbonaceous chondrite. But the interesting question is, did it come from a different parent than, let's say, Bennu? It's possible that both of these asteroids came from very different parent bodies originally in the asteroid belt, but it's also possible they came from the same parent body. In the process, we're going to learn about the nature of very large asteroids that are primitive in the asteroid belt.
It successfully reached Ryugu on June 27, 2018. It landed 3 hopping rovers on the surface of the asteroid. Some of these rovers have already sent home stunning images. However, the climax of the mission came on February 22, 2019. That day, the spacecraft was able to make the most complicated maneuver: the first touchdown. The probe was able to grab a tiny sample of dirt off the surface of the asteroid. It was the second time that humanity has ever achieved such a feat. These are the actual images of the historic moment of the first touchdown. Hayabusa 2 is hoping to bring back to Earth between 10 to 100 milligrams of material for in-depth analysis. The goal is to clarify the origin of life by analyzing samples acquired from a primordial celestial body, such as a C-type asteroid, to study organic matter and water in the solar system, and how they coexist while affecting each other. The other asteroid sampling mission that is now underway is NASA's OSIRIS-REx mission. On December 3, 2018, after a 1.2 billion mile journey, it reached its asteroid target, Bennu, and started to orbit. It is scheduled to bring back a sample of this mysterious celestial body to Earth in a sample return capsule in 2023.
The OSIRIS-REx mission launched in September of 2016, and it's a 7-year mission to go out to the asteroid. So we're going to reach the asteroid in 2018 and perform science studies of it through 2019 and 2020. And then in 2021, we will begin our return back to Earth.
The OSIRIS-REx mission will answer some key questions about the origin of the solar system, since, as an asteroid, Bennu is a flying fossil from our solar system's most remote past, and about the origin of life on Earth, since, as a carbonaceous asteroid, it may contain molecular precursors to the origin of life and Earth's oceans.
One of the reasons why we want to find out whether or not there are amino acids on Bennu is because we're not exactly certain how the building blocks of life got on Earth in the first place. One of the theories is that asteroids may have impacted Earth while it was in its early formations, and if those asteroids had amino acids on it, then it would have seeded life here on Earth.
OSIRIS-REx will determine Bennu's physical and chemical properties, which will be critical information to have in the event of an impact mitigation mission. It is scheduled to touch down on the asteroid's surface with the touch-and-go sample acquisition mechanism, or TAGSAM, that consists of a robotic arm with an attached sampler head.
We use the TAGSAM arm, which is kind of like a really expensive vacuum cleaner, which reaches out and touches the surface of Bennu from about 6 feet away and uses nitrogen to stir up the dust and the regolith that's on the surface of the asteroid. And that gets collected inside of a round collection plate, which we then store on side of the spacecraft and bring back to Earth.